Great. Okay, cool. Welcome everyone to the MYOB Richmond office. My name is Paul, so I'm the architect for our DevOps sort of delivery engineering team here at MYOB. So we've in the last year started on our journey with Kubernetes. So I think we've gone quite far through the motions, and access control was one of the things that we needed to look at. So tonight I'm just going to talk to you about OpenID Connect in Kubernetes. With the rise of software as a service and a lot of services that companies are now outsourcing, I think single sign-on is probably quite an interesting topic for enterprises and companies at the moment. So it allows you to utilize these third-party services while still sort of keeping your internal user setup, groups and audits and all that kind of thing. So I'm just going to give you some slides, just sort of an overview, some high-level stuff, and then go through and actually do a demo and actually set up OpenID Connect with Kubernetes using Auth0 and my Minikube cluster. So you can see there, that's the address if you actually want to have a look at these slides and look at any of the scripts I'm using later. So if you want to sort of dig deep and see how you might set this up for your company, you can always go there after the fact onto GitHub and have a look at those things. All right. So why? So as I've sort of mentioned with single sign-on and third-party services, the reason why you might want to do this, obviously, yeah, the main one, yet another password. So that's yet another place that developers need to set a password and work out what it's going to be and when they should reset it, etc., etc. So OpenID Connect allows you to hook into your current authentication mechanism for your company. So developers will just go through and just sign on as usual. So the developer workflow there is really great. It's really easy for them. And I'm going to show you tonight how you can do that with the Kubernetes Dashboard, the web dashboard. And I'm also going to show you how to do it with kube control. So you can do it at both the web UI as well as the command line tool. And they're both going to use the same setup. So it's going to sort of minimize the maintenance around that. So the other reason from the company point of view is having this in your standard user setup when you're onboarding people and offboarding people. It's a central point where you can where you can disable users or add users in without having to go and set up yet another system and tell them to remember yet another password. So along with SAML, OpenID Connect is getting quite popular. It's quite available, as you can see, for potential providers. You could hook this up to your Google account, GitHub, Twitter, the more enterprisey things like ADFS, Auth0, which is what I'll be using tonight, Okta, and any of the other ones. It's a standard specification built on top of OAuth2, so it's readily available. There's plenty of tools around for it. So you've got a lot of options there with how you connect it up, and hopefully it doesn't matter what you're using for your enterprise user management system, it will in the future actually offer OpenID. So before I go into the OpenID stuff, just a sort of quick run through with Kubernetes and its authentication and authorization mechanism. So RBAC has come into Kubernetes, and I think for 1.8, I think it's GA now. It's been in beta. Someone correct me if I'm wrong there, but I think it's in 1.8 GA. So it's now it's now a part of Kubernetes proper. So what I'll do is I'll just quickly step through the steps. So when we use kube control or just an HTTP client or anything to talk to Kubernetes, the pipeline that the client goes through is obviously you have your client or you have your web server or your SPA, a single page app, and that goes through the API server, and the first step is the authentication, so working out who you are, so verifying who you are and what groups you're in. It's interesting to note with Kubernetes doesn't have a user database or a group database. They obviously have role bindings and cluster role bindings, but there's no user database. So when you go through authentication, It's relying solely on OpenID Connect, so I'll talk a bit about that later. But it's just a different thought pattern than in most places. They'll have a user database where they'll store some user information, and you might need to create a user beforehand. But you don't need to do any of that with Kubernetes, as you'll see. So once a user is authenticated, that's when the authorization and the RBAC kicks in. So that takes the user details in the context of the current request and works out if that user is able to perform a certain action on a certain resource. So RBAC role-based access control, that's where that kicks in. And finally, the last part is admission controllers. So that allows Kubernetes, and I think with 1.7 and 1.8, you can even do your own custom webhook-based admission controllers. That allows you to put some custom validation around what people can do with certain resources. So that's just an extra level that's now more customizable. So that's just at a high level Kubernetes authentication authorization. So as I spoke about, so a lot like AWS IAM, if people use AWS with IAM policies, you have actions and resources. So it's the same kind of thing. I think it's called verbs instead of actions. And then you do verbs on resources, you get pods, or you list services. And it allows really, really fine-grained control. So you can say, this user is only allowed to get services of this particular name. So it gives a lot of fine-grained control, which is very handy, especially in the enterprise environment where you want to lock down certain things. OpenID Connect. So SAML was a big SSO kind of language, was it security assertion markup language? So that's been used quite a lot in the enterprise. OpenID Connect is a new specification that's just leveraging OAuth 2. So it's not in itself a new thing. It's merely sort of documenting and specifying how you're going to use OAuth 2. So that means specifying where you can find discovery endpoints and how you're going to encrypt and sign your, sorry, not encrypt, but just sign your JSON Web Tokens, what kind of scopes you can use, and set the claims that you can make in it. So I'll show you some more examples of that. So this is a very quick high-level overview of how OIDC and therefore OAuth 2 works. I might take a seat so I can just use my mouse here. So with OIDC, you have a couple of different actors within this flow. It's not like the old model where you just go through a web server and that web server authenticates you based on some database. What you're doing now is you have your client. So your client, which in the context of what we're talking about tonight is something like the Kubernetes Dashboard. So that's your client. And you have your provider, so OIDC provider, and that's your user system. So that might be Google or GitHub or ADFS. And then in our case, there's the dashboard and the Kubernetes API. They kind of go together as they're kind of sort of both the client. There's two parts, which I'll go through it a bit later because it confused me a lot, kind of trying to work out who's what in this interaction. So what happens is you go to your, in this case, the dashboard, saying I'd like access to something, and the dashboard will tell you to go to the OIDC provider. So the dashboard needs to have some information about who it trusts to authenticate users. So what it will do is it will just send you a redirect back to go to the IID provider. And within that redirect, as you'll see, it will send through certain details identifying it as the client of the IDP, the identity provider. So what happens is you as a user will follow that redirect and you'll get presented with your, say, Google login page or your GitHub login page, and you'll get asked to authorize this. This client wants you to log in, is that okay? And so it's up to the provider to authenticate you. So you're not handling any kind of security stuff around authentication and making sure they've got cookies or they've got MFA enabled. That's all up to the identity provider. So that's up to whoever manages your user management system. They can enforce whatever they need to enforce, whether they have two-factor authentication or password policies. That's all on them. So once you log in, and that login flow, if you've already got a cookie for that user management system, you logged in this morning and that cookie is still valid, then what will happen is you'll just get redirected straight back. So it's not going to impede your flow. If you're not going to have to log in every time. Once again, that falls onto your provider, your identity provider, to determine how long your login lasts before it'll log you out and ask you to re-log in. So once you come back from that, you go back. The provider will redirect you back through the browser back to the dashboard with certain details in the query strings, and then the dashboard will do a out-of-band HTTP post across to the provider with some other details, just to confirm that everything's kosher, and the provider will then come back with a JSON Web Token. So this is the opaque string that is used for authentication, and I'll go through that in a minute. So that's the high-level flow. It might be I found it very hard to follow when I first did this, so don't worry if it doesn't make too much sense. We'll go through a demo, and as I said, all this stuff will be on GitHub, so if you want to run through it as well, yeah, you're welcome to do that later. So yeah, JSON Web Token. So in OpenID Connect, it's called the ID token. So a JSON Web Token is really just a way of conveying data in a secure manner. So it's not encrypted. It's easily accessible by anyone who gets the token. So it can't be used to store any sensitive information, but it is signed. So you can verify who created that token. So you can assert that there was no manipulation of the token. And it's reasonably simple. It's made up of 3 separate parts. Each part is delineated or separated by a dot, just a period. And each of these parts is a JSON object that's just base64 encoded. So if we have time, I can get one and we can pull it apart and have a look at it. So the 3 parts are, there's a header. So the example here is, so this header just tells you, it's just some metadata about the token, how it's been encoded, what it is. So it's a JSON Web Token, and it's used RS-256 for the signing mechanism. The real important part is this second bit. So this is the claims, they're called. So this JSON Web Token is making some claims that whoever has this token, their name is John Doe, they are an admin, which on its own, obviously anyone can just base64 encode whatever they want there and forge it through. The last part is an actual signing from the provider of the above 2 parts. So you can cryptographically confirm that this web token has been created by the provider you trust and that it hasn't been tampered with. So John Doe is really John Doe and it's not some other name someone's hacked in there. So demo. So you'll have to excuse my horrible drawings here. I just wanted to sort of give a high-level idea of what we're going to do now for the demo. So what I'm going to do is I'm going to use Auth0. I don't know if some people have heard of it. It's kind of like Okta, or it's like a hosted user management system that supports things like SAML and OpenID Connect, obviously, and allows you to manage your users and connect into your AD and all that kind of goodness. But they also offer free plans, which is what I'll use tonight. So anyone can follow this at home later. You guys can all do this at home. So that's going to be the OIDC provider, Auth0. And then I'm going to use Minikube to spin up a cluster here, and I'm going to run a new dashboard. So normally when you spin up Kubernetes, a lot of things will set up the Kubernetes dashboard for you. What I'm going to do is I'm going to set up a new dashboard as another deployment within Kubernetes. I'm going to access it just via a service node port, but obviously in production you'd probably use an ingress. So what's going to happen is we're going to hit the dashboard. It's going to redirect us back to the provider where we're going to log in. Going to redirect us back to the dashboard. The dashboard is going to post back to the provider and just confirm we are who we are, and the dashboard is who they are. And then what happens is the JSON token that gets back is then attached to as a header to each request, which is then proxied through to the dashboard. So you can see here inside the dashboard pod that we're going to do, where we're slipping in an extra container as a proxy in front of the dashboard container. So the only port that is exposed out of the pod is this proxy container here. So all inbound requests are going to go through that. And that's OpenResty. I don't know if anyone's heard of OpenResty. It's kind of like Nginx with Lua, so it gives you some programmatic abilities with Nginx, kind of the best of speed and programmatic ability. So we're just going to proxy through requests using sessions if someone's already logged in with a JSON Web Token until they expire. And they'll just get forwarded through to the dashboard. And the dashboard has a feature built into it that if it receives a request with an authorization header already on there, it will then just proxy that through to the Kubernetes API. So what we're also going to do is when we spin up the cluster, as you'll see, we have to configure the Kubernetes API server to trust a certain provider and give it those details. So when the API server receives this JSON Web Token, it can validate it and it knows to trust it so that it will allow access based on what's in that token. So that's kind of a high level. All right, so let's get down to the demo. Now, which way are we? Okay. All right, so actually, first things first, I'll show you Auth0 and the setup there. Now I'll make it a bit bigger. Is that big enough? Let's see. So this is the Auth0 dashboard. So as I said, clients is the terminology where you want to allow a third party to trust you. In this case, as an identity provider, a client will be trusting Auth0. And so what I've done is here is I've created an OIDC test client. And you'll see that when you create a client, you get a client ID and a client secret. So this is a standard thing, doesn't matter whether you're using Auth0 or something else. And that's what's kept inside the dashboard. And the client secret is used by the dashboard to talk back to the OIDC provider and say, just to prove that it is a valid client. And the client ID is a public thing that actually you'll see that's the thing that gets redirected across in the URLs. The other thing, just to make it a bit more secure, is normally you'll need to specify the callbacks that you'll be asking the OIDC provider to redirect you back to. So in this case, the dashboard, you'll see here, I've got some. This will be the Minikube IP, and this is the node port that I'm exposing. So if you ask it to redirect to some other URL off in Hackerland, it won't let you. It'll only go back to certain URLs that you've input into Auth0 or your identity provider. So that's that. So this thing here and this thing here, the client ID and client secret, are the important bits. And also making sure the redirect URIs are there. So I'll just make sure I export these secrets and ID and secret. So we've got those. We'll hide those away now. So we're ready to go. Let's spin up a new Minikube. So I'll just make sure we're starting fresh, getting a brand new one. Hopefully the IP, because sometimes the IPs change, so hopefully it'll be an IP I've added into the callbacks there, but we'll see. Okay, so what I'm going to do now is I have a script here, which these are all on GitHub, as we said. Oops. In the demo folder. Oops. So this is just the standard Minikube start command. But what I've added in here, you can see I'm setting the authorization mode to RBAC. So what that does is that means that you can't sort of just log in, there's going to be more complexity around making sure you've got roles and cluster roles and role bindings and things like that. And then these OIDC configurations here, you can see what they're called on the API server flags are up here. And this is where you tell the API server that you want to enable OIDC, and here is the issuer that you trust. So you get this from Auth0. Yours will be different, obviously, depending on who you sign up as. And what we're putting in here is the client ID. So that's specifying, that's linking the API server to trust this particular client that we've created. And then you can also configure if your ID provider sort of has some quirks around the claims that it gives in JSON Web Tokens. You've got some flexibility there to change them. So I've just said, so Auth0 will send back an email claim and a groups claim, which we'll use, the email claim we will use to identify someone. So that's what shows up in audit logs on the API server. And then the groups is the claim that it will try and match a group to a role binding to see if that particular request has access to do something. So, spin that up, might take a couple of minutes. Any questions while we wait for this to spin up? No, that's cool. So, what I'll do while we're waiting. So while we're waiting for that, I'll just show you the next part. So the next part is just putting those secrets into Kubernetes. I'll make it a bit bigger. So the dashboard that we boot up is going to need those, the client ID and the client secret. So we're just creating a Kubernetes secret as you would for any sensitive data. So hopefully that's up now. Let's just make sure and get the So .43. So we have to make sure that we're allowed to redirect back. I already anticipated that would happen, so that's in there. So if we go here just to have a look at the sorry, it's 30,000. Excellent. Now this is the standard Kubernetes dashboard that just comes built in. You'll notice now though that I'm getting all sorts of errors here around not being able to access things. So that's because of the RBAC that's been enabled. So it's anyone that isn't really authenticated sort of gets the default user, and that default user can't do anything. So that's why that's happening. So we've got that all set up now. I'll create the secrets. Cool. All right. So the next thing to do will be to deploy the dashboard. So I'll run that now, and I'll show you. That's just deploying the dashboard into the Kubernetes, and I'll show you what that looks like. So all that's doing is doing a bundle.yaml, but if you look at the bundle, so this is probably like the meat of the problem. The API server, the Kubernetes API server, will happily trust JSON tokens that you've set up with your issuer and your client ID. The problem that you need to fix is how do you get those tokens issued? So the identity provider supports OpenID, and it will issue tokens if someone goes and does the correct flow with all the correct bits and pieces together. But you need something in the middle between the dashboard and the ID provider to actually work out that flow of redirecting through, waiting for a login, having a redirect back, picking off the code, posting that through, and getting back the token. So the meat of that is in this OpenResty container. So what's happening here is the OpenResty container is exposed as a container port. But you'll notice that the actual dashboard container up here, obviously it's got a port open for its endpoint, but there's nothing exposed out of the pod. So no one can actually directly hit the Kubernetes dashboard. They have to go through this OpenResty container here via port 9000. So what this does is it uses OpenResty with so OpenResty is Nginx with some Lua scripting in it, and someone has written a OpenID package for Lua. So what this does is in this config map, we set some things like the client ID, the client secret. You also set a discovery endpoint, which is an OpenID thing. It's a standard endpoint that is in the specification that people know if they're given that endpoint, they can pull out things like where they go to authorize, where they go to generate a token, where they can go to find the public keys to verify the signature of the JSON Web Token. And so we run that package, and that does all the hard work in terms of redirecting across, saving a session, allowing you to come back, pull out the session, do some checks on state and encryption nonces and all that kind of jazz. And then at the end of it, we'll give you either an error or a response. And if there is an error or there is no response, then someone hasn't been validated properly, and we just return a 403. Otherwise, we come through and we set the authorization header with the JSON Web Token that this OpenResty OpenIDC package has got for us. So that's then set, so the ID token is in the session, so that if they have a cookie for the session of this OpenResty container, then they can come back through again for the time that the JSON Web Token is valid. So inside a web token, there's a JSON Web Token, there's a claim that says how long it's valid for. It's usually maybe an hour. It can be shorter, it can be longer. But what that means is that when that's no longer valid, you need to go back to your identity provider and get a new token. So this little package here honors that, and will redirect you back again when the token expires. But in the meantime, it'll store it as a session. So that's kind of the meat of that, like that orchestrator that makes sure that it talks to the identity provider and it talks to the dashboard, which then talks through to the API server. So we've got all that deployed now, hopefully, so successfully rolled out. So what we should hopefully see is so that the node port I put it on was 30,004. So hopefully this works. That happens very fast there. So what happened is we went to the dashboard. The dashboard said, no, you've got to go across here first. And what it's done is it's put the client ID in there. Auth0 has then redirected us again because of its single page appiness. But it's forwarded through. We've specified the redirect URI that we want to go back to. And this is the URI that is checked against the Auth0 client list in here. And so if it's not one of these allowed things, then you just get an error and it won't let you go through. So what I have here is I've set up a couple of users just to show you how the groups work. How are we going for time? I think it's made it too big. So what I've done with Auth0, it allows you to set up some users. So we'll start with test one here. So test one, it has an IDP group called test one. So what will happen is that group will come through in the JSON Web Token. So we'll log in. I've logged in before, so it should just pull me back. So we're back in. We've got the thing telling us that it knows who we are because it's saying my email address there, but I can't do anything. So that's the first step. So we've at least got an identity now within Kubernetes. But we can't do anything. So next step is we want to create some role binding. So I've got another script here that's going to create some namespaces and then tie some role bindings to these two namespaces and have an admin namespace. So my group in auth 0 for this user is test 1. So what happens with the API server is that the API server will try and match that group or any of the list of groups across to role or cluster role bindings inside Kubernetes. So you can see here the name of this role binding is test 1, so they match. So Kubernetes will allow my JSON Web Token access to do anything that this test 1 role can do, which in this case it can, it's got to edit, but only within this test 1 namespace, so it can't look at any other namespaces. So I'll deploy that. And was I up to 4? Deploy, yes. And now the JSON Web Token should still be valid, but now Kubernetes has been updated, so that won't do anything. I need to go across to... Okay, so that's worked. So now I'm in the test 1 namespace, which is what that role binding allowed. And you can see now I'm not getting, there's nothing in here, but I'm not getting any role denials. And you can see here, I can see the default secret, which is created when you create the namespace. So if I just assert that if I can't, I can't look at kube system, for example, because this role doesn't allow it. That's actually still, that's a bug in the dashboard. That's not showing me. And then there's a bit of a bug in the dashboard where it kind of doesn't like it if you change things there. Okay, well now there's a real, let's just start again. Okay, big bug. There we go. So if I come through, change, yeah, so now it's saying my user can't access kube system. So what I'll do is I'll just show you how, if I compare that to, if I log out, come back in again, I've logged out, so now the session's gone. It's going to come back here and I'll log in as someone else. I'll log in as the admin. And so this user has an admin cluster role, so it should be able to see a lot more stuff. So already it can see the default namespace. It can actually list namespaces. You can see kube system namespace. So I've got an issue with my DNS, but that's all right. So it has a lot more access. However, it doesn't have full access. Can't see node level stuff. So it gives you a lot of power to use your identity provider. You just can put people in certain groups, and as long as your identity provider can just send through those groups in the JSON Web Token, those groups can be honored inside Kubernetes. So that's great for the web dashboard, but obviously you're going to want your developers to be able to use kube control as well. So what I've done is I've hacked up a little script that will essentially do this for you. What we do is we basically copy how Google Cloud does their OAuth 2 OpenID authentication. I don't know if anyone uses Google Cloud, but what you do with their command line tool is when you say log in on the command line, they will actually open a browser, and then you will go through your normal Google login flow through the browser, enter your MFA details and whatnot. And what they do is they run a browser in the CLI tool. So when you run the CLI tool, they actually boot up a local host browser, and they tell the web browser redirect to Google to redirect back to localhost, where they pick up the auth token and then do a post and all the magic happens. So the same thing I've written up here, is that number 5? So this is just Ruby. I just needed to do it quickly. We're actually working on a tool that will do this in Go, so it'll be a static binary that will do the same thing, that anyone can use for to hook up an OpenID provider for Kubernetes. So what it does is it will set up all the URL stuff here. So it just sets all the what it's asking for, the client ID, redirect URI, scope, and all that. Further down here, I'm going to have to go up and down a bit. It's going to open a web browser, which is that part of it's going to go to the IDP and ask you to log in. And what will happen is it's booted up a web server, so that when the IDP redirects you back to the local host, this little tool will pick it up on the web server and do the exchange and write out a kubeconfig file. So you can see here I've just written a kubeconfig file, and it's just going to add in things like the token. So kubecontrol actually supports natively the OpenID Connect setup, but what it requires from you to put inside your kubeconfig is things like the client ID, the client secret, and it will do refresh tokens for you. So it's actually quite complex if you wanted to do it with the native setup, whereas this thing will, as a developer, just sort of send them across, log them in, write out the whole thing, and they're good to go. So this uses the token method of authentication, which is really just taking that token and putting it in the authorization header as a bearer token. So we'll give this a run. Now I think I have to put in, so it's 40. So I'm just putting in, I need to, obviously when you write out your kube config, you need to have your CA details in there for your cluster, obviously for security. And I've just little hack there to put in the last number of the IP because it keeps changing in Minikube. So what it's done is, it's opened the web browser, redirected me across. Now it's turned on the web server and it's waiting for me to come back. So when I click on this, you'll see stuff has happened. It's got a request back and it's done some stuff. Just for debugging purposes here, I've just output what the JSON Web Token is that came back. So you can see some claims in here. So it's set the email claim to be my user, and it's set the group's claim to be this group here. It's got some other things like my email's been verified, and some standard claims like who's the issuer of this JSON Web Token, and the subject and the audience, and some cryptography stuff there. So what it's done is it's output a kubeconfig file here. So it's just taken in the CA user data, certificate data, put in the address, and then the important thing is this token here. Oh, very loud. And what we can do quickly is just show you. So this is just a website you can go to debug JSON Web Tokens. So if we put it in here, we should see that it's JSON Web Token using this kind of algorithm. A key ID is used for the checker of the token, so the API server, to go to the discovery endpoint and pull back a public key for it to confirm that the signature is valid for that particular OpenID provider. And then here are all the claims that we saw above. And so this third part here, that's to do with the signing stuff. So now we've got our kubeconfig. We can just specify here we want to use the new one. It's auth. I don't think I'll be allowed to do that. No, but you can see it's got my name there. But we can get some pods. So what developers will need to do is these tokens, there's an expiry key down here, which is in Unix time, so I'm not going to guess what it is, but it should be an hour. So what will happen is in an hour, this token will become invalid and it won't work anymore. So every hour, a dev would need to rerun that console application to get a new token. Which, yeah, in my experience, hasn't been too annoying. It's just a quick, simple command. Everything kind of happens automatically, especially if you've already logged in. So it seems like a really good flow that sort of helps companies to maintain their requirements around user management, but makes it as least friction as possible for devs. So I think that's about it. Thanks for listening. Sorry it was quite in depth, so hopefully you got something out of it. If, as I said, you're welcome to go to GitHub and sort of have a play around with all these scripts yourself. Auth0 is free for if you just want to play around, so you can go sign up to Auth0 and do this as well. Yeah, any questions though now? No, thank you. Okay.
When's the Go tool come out?
Sorry,
When's the Go tool?
So it's actually up on GitHub at the moment under our MYOB technology org. So it's actually out at the moment. We've actually got to do some tweaks though to make it more compliant. So at the moment, yeah, it's not quite working. So I wouldn't recommend using it just yet. It's called Configurator with a K. So Gus, who's here tonight, is the inventor of that. So we'll be doing some work on that just to make it into a standard OAuth 2 implicit grant, which is what I just showed here. And so anyone will be able to take that, give that out to their devs, and just input the specifics to your identity provider, and you'll be good to go. That's the beauty of this open specification, that you can write tools for you that help more than just you. Cool. Alrighty.